Okay. So next, we're gonna hear about the Roman chronograph instrument integration campaign by Gasia.
Good morning, everyone. My name is Gasia Bedrosian, and I'm the integration and test lead for the chronograph instrument. I'm going to give an overview of our campaign and just you'll see some similar photos from Milia's presentation, and I'll kind of break down the start to finish.
You have to click on your present. Now, click.
Yeah, okay. So I wanted to start out by giving the integration and test hierarchy just to give everybody an overview of how the deliverables were. So here's the chronograph instrument as a whole, but it started out all the way at the bottom with all the elements that participated: MTS, optics, active optics, camera, avionics, and they built up all the various elements of CGI, which formed the various pieces, which were the palette and the optical bench. And then INT put together the cameras and the DMs as well. And then here we had the built up chronograph instrument. So it took a village to get this to where it is today. So some special challenges that we've had for INT is we're a very complex instrument. However, we were a class D, so we had this paradox to deal with. We had a lot of requirements, a lot of complex electronics and optics and software. We had to deal with a lot of elements such as thermal control and just our unique designs for electronics. So we had a lot of challenging contamination control requirements to deal with as well. So we had very, very close contact with our contamination control engineers and our optical engineers throughout the process, and did lots of little cleaning parties along the way to make sure that the optical bench was as clean and pristine as possible and kept it covered as much as that we could. Also, we had a 54-day thermal vacuum test. I will never forget that it is 54, and I'm sure whoever participated will never as well. But it was the most wonderful 54 days because we got to experience the chronograph come to life for the first time and just give us the results that everyone had been waiting for. So as we've alluded to, the chronograph is very close to the size and the weight of a grand piano. And Charlie kind of put together this slide at the very beginning. And so we thought about this a lot. We wanted to take a picture of someone with that, but I don't think we ever really got to that. So, but there it is. And so that, therefore, if you ever visually think about it, kind of gives you a concept of how chronograph. So the INT campaign spanned from July 22 to May of 2024. And here's kind of a snapshot of where it all began. We received the bare electronics palette with the heat pipes and no electronics. And we received our optical bench with some surrogates of the DMs and all of the flight mechanisms aligned. And it was also missing the camera. So here's where we kind of started. But then we kind of hit a very big challenge. We received our instrument control electronics and our precision alignment mechanism electronics. However, we kind of stalled there for about 6 months because the avionics team had a huge challenge ahead of them where we had to replace 14,392 resistors on the DME boards. And that was a huge challenge. We all kind of supported the avionics team and worked together and focused on that to help them get through their campaign so they could deliver the rest of the boxes. And that's why our INT campaign spanned so long, since we were waiting for our electronics palette to be complete. But we got through it. We worked together. We came up with innovative ways to utilize cross-team members across the board to get this done, and we made it through. And in August 2023, we achieved that milestone, and we had a built-up palette, a built-up optical bench. And yes, along the way, while we worked on the optical bench, our camera installation was complicated because it involved our proximity electronics and thermal straps. We leaned heavily on our HoloLens, and I'll talk about that more in the upcoming slides, and a lot of fit checks to make sure that we had the right GSE to get those cameras installed in a line. So there was a lot of pre-work that went into that, and we took advantage of the time that we had between getting all the electronics processed to get that nailed down. And then we got to the point where we had to integrate the instrument, but it was a very, very complicated process, and it involved about 4 lifts. First one was getting our pallet on the fixture. It was lifted into the integration stand. So it was on that Flowtron before and it got lifted. And then we had another lift number 2, where we lifted it then to its offload frame. And then here we had the optical bench where we lifted that onto the offload fixture right on top of the pallet. And that was the 3rd lift. And then we had the biggest lift of all, the 4th lift. And here's kind of a time lapse where you could see where we got it lifted onto the assembly platform. You guys can down to that. That was a huge challenge for us because we needed to get our bipod attached and it had to be flight-like. So our solution was to lean heavily on metrology. So we positioned it and we had real-time metrology, make sure we were in the right position. And we also heavily relied on our HoloLens, which is a 3D superimposed view of what a CAD model is. And we'll have some images later where we practiced this visually to ensure that we had it down as good as we could. And actually the team got it done and it took full day, but we got it done and we got it done on the first time. So it was a really, really huge team effort. But then here's a photo of the completed optical bench. We got it done in the August-September timeframe of 2023. And you can see the electronics palette on the bottom and the optical bench on top. How did we get from start to finish? It took a lot of planning to do the execution. So we started out with an INT flow, and this was presented at PDR. And you can see as we go through these different flows how we evolved from a very lengthy campaign of 2 TVAC campaigns before we even went to environmental with a TVAC afterwards. And then we kind of got to CDR, and you'll see a drastic change where those TVACs no longer exist because we did get the Scope 2 class in tech demo. So in lieu of that, we chose a full functional test in air, which Ilya alluded to earlier. And we just did some tweaks and changes, and we brought down that TVAC test down quite a bit. And then we went to SIR, which was about June of 2022, and more changed where acoustics was replaced with modal testing, and we just revised the flows and the general scope of each test. And then actually what was implemented slightly differed because right after SIR is when we found out about the avionics DME replacements, and the INT flow just had to start from scratch again. It shifted about 6 months to the right, where if you see here, we kind of had a 62-day storage period where we would be done with INT so much earlier, but in fact, we had no storage days. By the time we were done with TVAC and finished everything, we packed up and went to Goddard. But it took a lot of different changes, but the key thing to note here is that we collaborated, we met daily, we came up with different ways and innovative ideas to change the flow and come up with ways to meet these schedules. And we shifted them almost on a daily basis sometimes. So how we got there, communication, innovation, and teamwork. Can't stress that enough. From post PDR through SIR, we faced a lot of challenges. First one was INT planning was done mostly in the COVID era. And so we had to have regular meetings. That was really, really important because a lot of our team members actually didn't meet each other for about a year until after we started coming back to lab. So having those meetings was very important to ensure we understood what the scope and what the objectives and what the requirements were for INT in order to get a proper flow. Also, our D scopes led to a lot of INT scope changes. So again, lots of collaboration. And once we started INT, our daily INT meetings were absolutely crucial because we all had to meet and discuss our plans and make sure everybody felt comfortable with what we needed to do and when we needed to do it. And we worked through it. We went from a full, from a full pallet avionics TVAC to just a bake out, because by the time we got to that point, we only had 2 avionics boxes and not 6, but we just took what we had and we did a bake out with that anyway. So we worked with the best that we could get to do what we needed to do. Also, we took that time, we did a lot of preparation on our mechanical GSE, our EGSE. We had a lot of early functional testing that we were going to do initially. We called that side-by-side testing, then we called it vertical testing. All those got de-scoped, but we made time work the best that we could with what we had. And our DM and camera installation was initially supposed to be done during optical INT, and it was moved over to our integration and test. So we also incorporated that into our daily INT flow, and the optomechanical team actually supported us, and it all worked out very nicely because we all collaborated together and got that job done. We heavily, again, used HoloLens, and also upcoming slides will show that, to understand what the nuances of our integration and test were, because a lot of that helped us get through our INT campaign very, very smoothly. We also had a harness mock-up, and that really helped our harnessing team and getting our thermal hardware practiced so that we knew how to get the harnessing done once the time came. So here's some HoloLens activity snapshots. We started very early, as soon as right after PDR, which is years before INT, and we kind of met as a team, and we started working on these activities to try to envision what the optical bench and the pallet would actually look like. And if you notice, you'll see furniture and people surrounded by that, but then you'll see like these CAD models in the middle of the floor. And that's because it's like 3D CAD models that are superimposed on reality right in front of you. So as soon as you put those virtual glasses on, you'll see the instrument come to life in front of you. So we had team members on the floor under those 3D images of the instrument, trying to understand. It is during these HoloLens activities where we were able to understand that perhaps we weren't able to do the lift a certain way, or perhaps do harnessing a certain way, and we came up with harness bundles, cable racks, and just different methods. But this was absolutely useful, and we actually ended up using them during INT and brought these HoloLens glasses with us in the high bay and actually practiced doing TVAC configuration and lift configurations ad hoc on a daily basis right before the actual activity, so we could kind of get a visual sense of how that would go. And here's kind of just a video of our mechanical engineer who had this HoloLens on, and you can see he's kind of looking at that model of the structure. So he can kind of get a sense of what our TVAC configuration looks like without actually being in that configuration, and that helped us quite a lot. And again, as I alluded to the harnessing mock-up, it wasn't not only used for fit checking, but also thermal hardware routing. So you can see that they were practicing routing the thermal hardware. And because of this, they came up with more innovative approaches of how to do our thermal hardware. And that's kind of what our instrument mock-up looked like. And so that helped us a lot because, as you can see in the first picture, it's a bundle of harnesses, and that's just the pallet prior to when we integrated. You can see that that's a lot of harnessing that had to be connected between the pallet and the bench. On the second one, you can see how it all kind of neatly came together as we started harnessing with the DMs. And you can see on the third picture, we're using nep tape wrapping. So The team used this NEP tape, and that was kind of the first time that a project kind of really utilized that approach. It was used for contamination and shielding. So a lot of planning was done a couple of years in advance, where they looked at the traditional EMI tape versus NEP tape and found that NEP tape was better for contamination and shielding, which is very important for CGI. And so therefore, the team worked on getting those NEP tape on all of the harnesses prior to when we installed them for INT. And we also took the approach of splicing all of our thermal hardware before it came to INT. Usually this step is done during INT, but because of all the contamination issues and all the work that you have to do on the bench, the thermal team learned while using the harness mockup that it would be better to do that before, and it minimized contamination during our installation. So then once all of this was done, we were ready for our full functional test, and you saw this picture before. We had a lot of planning and prep that we had to do for this test because it was the first time that we were in this configuration, the first time that the instrument would have to come together. So we had a lot of dry runs of our GSC beforehand. We had a lot of PBATs that we had to run, which were our procedures for these tests. And all of them we utilized on the test bed for dry runs. And our biggest lesson in FFT was that we learned that ensuring a thorough walkthrough with all subsystem leads prior to our configuration would have really helped us a lot. And the reason for this is there was a thermal wire in our beam path that we found during full functional test. It was a very simple solution. Actually, during the test, we had Brian go inside the high bay and we actually wiggled the input beam in the direction we watched it get better. And we learned that indeed it was a thermal wire. It was simple, but we learned that just by making sure that we had done that walkthrough before, we would have moved that thermal hardware out of the way. Cool. And we also found several issues that we fixed, like Ilya said, during FFT and some after. Our EMI-EMC test. Some methods that we used that were very important for EMI-EMC planning was we did a fit check of our actual configuration of going in with our mass model beforehand. And we also worked with the EMI-EMC group to get an HVAC system because maintaining temperature is so important for this test. So we needed to make sure our cameras did not warm up too much. So we had a special HVAC system installed right outside the chamber and kept that operating throughout the process. In our dynamics testing, you saw this video before, but what was behind all of this was multiple lifts that we had to get the instrument into different configurations. So methods that we used is a few months before this test, we did a practice run of a dry run with the mass model on the configuration for the GSE. That helped us understand the lift a lot, but we did face some challenges and we learned that actually a one-to-one comparison would be running a full instrument dry run. And so that's a good lesson learned. And also we were using this new software during Vibe. So that helped, that really kind of was a big challenge for us to get through that hurdle. But overall, the test was successful. Our thermal vacuum test was 54 days that spanned from February to April of this year. A lot of challenges were faced during this test, like we learned as we were putting the instrument together, this configuration, you can see there's a lot of MLI. A lot of that MLI was actually created on the fly in the high bay by our blanketing team. Because as we started putting together this picture, we realized we needed way more MLI than we anticipated because this configuration was a monstrous size. So a lot of MLI got done right at the end. Protecting our light source optical fiber, we learned again at the last minute, we needed to wrap that in order to ensure that it maintained its temperature. But the team came up with a great way of actually going in the chamber, wrapping it right before the test. So a lot of teamwork there. A lot of daily challenges were faced because every day we went through our sequence of testing, we learned that we had to reshuffle the order again in order to get us through the next day. So Ilya and I felt like we probably met twice a day at that point and worked on our staffing plans and our schedules to make sure that we got the tests that we needed to get done, or any special tests that any one of our coronagraphers came up with to get things done. And overall, at the end, it came out to be very successful. Finally, once we were done, we had to do some pre-ship testing, which we repeated at Goddard. And the methods that we used was we came up with this test very early on, and we actually ran it prior to dynamics and after dynamics, so that by the time we ran this at pre-ship, we had it down. And so when we ran this test at Goddard post-ship, things went very smoothly, and we got the results that we needed. So in summary, we had a flexible, resilient team, and that was very key in coming up with all those creative solutions that we use for schedule and our budget challenges. We really leaned in on technology like the HoloLens, using those new methods with the NEP tape and the thermal hardware installation. We utilized new approaches, like I said, the NEP tape. We worked harmoniously throughout the campaign. I can't stress enough how well our team worked together from all the elements, especially during TVAC, where a lot of people met each other for the first time, but yet these shifts went very smoothly and we got what we needed to get done. And we also looked ahead daily to ways to maximize our schedule. Every so often, every time we met, we were able to shuffle the flow around and find better ways to save time or do an activity before or after we thought that we could. And daily and open communication was crucial to our success, as that allowed everybody's voice to be heard and to ensure that we had a good campaign. So teamwork makes the dream work, and I can't stress that enough. So go team. Thank you.
Yeah, it's really impressive to see that you were always like chasing that moving target. I really like the slide where we can show that flow completely changing over time and even on shorter time scale. So yeah, kudos on that, and the team adapting so fast. Amazing. Any questions from the room for Gasia? Chris?
Yeah, you spoke to, having to revisit the timeline and the flow of everything on a daily basis, and how do you communicate that to your team and keep everybody informed without it completely occupying all of your time? How do you do that efficiently?
Well, we had daily meetings every day where we walked through. We had a daily calendar, and the daily calendar was basically our schedule laid out in a calendar format, and we walked through the day before, that day, and coming days, and about every few days we looked ahead, and that's how we were able to communicate it. And I sent daily updates out every single day for about 2.5 years. Every day, I never stopped, and updated everybody with the flow, with some images of what we did. And so everybody on the project, regardless of which element they were from, knew exactly what was going on at any point in time. I think open communication was the best way to get it done.
During QX, three times a day shift change meeting. So everybody can call into the shift change meeting 3 times to give.
Yeah. So it was kind of an open space where everybody knew at any point what was going on. So
An activity report was also.
yes, and we kept shift logs. And so those were always available to anyone on the team. So they were able to log in, look at the reports, and see how the tests were progressing at any given time. So there was always real-time information.
I had a slight question about one of your slides. HoloLens, how much did that impact you positively on your time management with the project?
I would say that that saved us weeks of time, because this complex lift, we started, like I said, this planning about 2 years before INT. And that really helped us nail down what kind of GSE that we needed and the amount of time that we needed to put in. So yeah, definitely shaved off so much time.
All right, let's thank Gasia one more time.